Good morning, everyone. In this chapter, we have studied about what is cloud and how this cloud will work. Today, we are going to start with the new topic, that is fog computing. Now, let us understand what is fog computing, how this computing will work, right? Related to IoT. Now, the Internet of Things, as we have seen that it's having billion of services, right? Whether it's related to cloud or anything, right? So it's having million and million of connections and services provided by the this IoT, right? So fog computing plays a very important role. Now, the concept that is given by the Cisco on January 2014, which extend the concept of cloud computing, but at the edge level, right? So this concept would come by would come on 2014 January, and it's given by Cisco. So for fog computing, edge computing, mist computing, fogging, and cloud-based. Right, so fog computing is making use of decentralized services in between core network, right, and the network edges, right, for data processing and to serve the immediate requirement of the edge system. So this fog computing is used to make it's used to make a decentralized server, right, that will work between the network core and network edges, and it will provide some data processing task, and it will help to serve them in a immediate and a frequent manner to complete the requirement of the end system, right? So processing and storing of data between cloud and end services, that is the also main work of fog computing. Now this fog computing is a way of providing compute and storage services that is more immediate and close to the physical devices. This fog computing virtualized platform that perform compute, storage, and networking services between end user and the traditional clouds, right? So it has been working between the cloud and the network layers, right? So that is the main work and thing that fog computing will provide. So it is a paradigm that extends the cloud computing services on the edge of the network to address the emerging IoT visions. Now, as we all know that cloud environment or cloud may be geographical a long way away from the main organization, right? At what the application will working and the things, right? So it's really heavily on the wider wider internet bandwidth, right? So it's geographical located at the long way from that of the cloud environment, and thus it is totally working by using the internet, right? So bandwidth, it will really take an heavy or wider internet bandwidth, right? So fog services are much closer to the end users, right? So what cloud will do, it will sync all the data that is generated, right? But the fog computing, what it will do, it will filter all the data, and it will filter the required data to the end system, and it will provide those data. Fine, so somehow it will do the data filtering work too. Now, this fog computing will reduce the need of bandwidth by not sending every bit of information over the cloud channel, right? As I have already told that it will not send every bit of information over the cloud channels, but the metaphor fog comes from the meteorological terms from a cloud close to the ground, right? Just as fog concentrate on the edge of the network, right? So it will work like that. Here next terminology is fog nodes. Now the network edge is what? It's an application and host router close to the end system in the internet. And network core is what? It is connected router in the internet or network to networks, right? That is called network cores. Here, fog node can be deployed anywhere with a network connection on a factory floor, on the top of power pole, etc. Right? So we can develop and we can place those fog nodes or deploy those nodes to anywhere. Right? So any device with a computing or storage and networking connectivity can be a fog node. Right? Fog node किसे बना सकते हैं जो डिवाइस है जो स्टोरेज कर सकता है, else networking, network connectivity, or else it will provide network connectivity, or it's having the computing storage, right? So this will the device will act as a fog node. Like example, some of the example I have given here, that is industrial controller, then switches, routers, embedded servers, etc. Right? So these are come as an example for the fog nodes. Here it shows the diagram of IoT and cloud, how different services and things are connected to the cloud. But this shows the fog computing, right? It's between the end system and cloud, right? So it's somewhere there in the network core and the network edge, right? So fog computing, what fog computing will do, here there are three layers cloud, that is fog enterprise model will be there. So what it will do, it will take some data from this, suppose there are three systems, end users will be there, and they are taking giving some data, right? So data mainly here in IoT we have already seen that there is data that also include the different kind of sensors, etc. Right? So every value should be considered as in data, right? But it is not flexible, or it is not mandatory to store each and every data into the cloud, right? So for that fog computing will work, right? So it will take data from this particular end system, it will compute it, take some actions, do some necessary actions, filter data, and it will sync those data to the cloud, right? So this is how this fog computing will work. Now need for fog computing, it's just a minute. Okay, so need for fog computing is for, as I have told, that IoT is generating number of data, that is the volume of this data is very high, right? So by that time it makes the cloud for analysis, the opportunity to act upon the data might be gone, right? So lots of data, or we can say that lots of useless data are been pushed to the cloud, right? So to filter that out, the useful data from the useless data, fog will do that thing, right? So fog filter out and send useful data to the cloud, right? So why can't do all in cloud? So cloud computing frees the enterprise and the end users for many details. That is, the breach becomes a problem for latency sensitive applications, right? Why can't do all in end system? So physical constraints would be there, energy, space, etc. Right? So this is the way, this is the reason why can't we do this fog computing or fog thing into the cloud and into the end system, right? So fog is plays a very important role when it's come to the data filtering. Does this replace the cloud? Things to remember that fog computing is a non-trivial extension of cloud computing, first of all, and it works on the edge of the network. And in a fog environment, the processing takes place in the data hub or on a smart device or in the smart router, or we can say it gateway, right? Thus reducing the amount of data sent to the cloud. So it is important to note that the fog networking complements, not replaces cloud computing, but fogging allows for short-term analytic at the edge, and the cloud performs resource that is intensive long-term analytic for that. Suppose that it's a use case one, a smart traffic light system STL is shown here. So this STLC calls for deployment of a STL at each intersections, right? So this STL is equipped with the sensors that will be generating the data for the cloud. So measuring the distance and speed of approaching vehicle from every direction. Second, it will detect presence of other vehicle crossing the street. Right, so now here the issue is what it will slow down and warning to vehicle at risk to crossing in red and even modify its own cycle to prevent collisions. Right, so this one is the use case one. Now in this STLC, that is system outline, what it will do, it will having the three laser rule, that is accidental prevention, collision relevant data to evaluate and improve the system, right? And third is maintaining safety flow of traffic, that is green wave along with the main road, right? So for this goal one is require real time reaction for that. Second, it requires near real time, and third, it relates to the collision and analysis of global data over long period, right? So key requirement for driven this is first one is local sub latency, that is a reaction time needing to the order of less than 10 milliseconds, right? So it should be like that. Secondly, it's interplayed with the cloud, that is data must be injected into the data center. Cloud are deeply analytic to this identify pattern in traffic and city pollution, right? So it should work in that particular manner and with that much speed, right? So use case were discussed bringing up the attributes here, that is and differentiate the fog computing platform from the cloud, that is application that require very low and predictable data or right. So it's taken use case of STLC and SCV. Secondly, geo distributed application will be used, that is pipeline monitoring, and STLS will be used. Fast mobile application, that is smart vehicles connected via each other and like with the system. Next, large scale distribution control system will be used. IOT will bring big data with the twist rather than high volume, the number of data source distributed geographically, right? So these are the key attributes for the fog computing. Now this use cases where we can use this fog computing, like smart home and cities, then connected vehicles, right? So computing, cloud computing versus fog computing, if we say this, then cloud computing is a practice of using a network of remote server hosted to the internet to store, manage and process the data first of all, whereas a generic term for anything that involves delivering hosted service over the internet. It is a paradigm based on the pay as you go, right? So cloud-based services would be that SaaS, PaaS, and IaaS, right? Now let us jump to the benefits of cloud. Now the main benefit, there are various benefits of cloud services or clouds. So first is it will cost saving with respect to the capital investment. First of all, we do not need physical rooms or anything like that to store any data or something like that. So it will have the cost saving with respect to the capital investment. First of all, it will reduce in cost with respect to developing and delivering IT services. First of all, right? It will also reduce the management responsibility, personal focus on the productions. Then it will increase business agility to allow enterprise to meet the need of rapidly changing market. On-demand self-service, resource pooling, rapid, elastic and scalability, major provision to optimize resource allocation, right? That what we have already seen in cloud computing, right? So these are the basic and main benefits of cloud. Right, so cloud-based services are storage as a service. What kind of services it will provide? So storage as a services, database as services, security as service. It will also provide communication as service, integration as service, business as service, testing as service, then management or governance as service. Right, so it will be used in almost every
scenario and almost every services, right? So here we have a difference between the fog and cloud computing. So response time is in fog computing and in cloud computing, right? So response time in fog computing would be milliseconds and subseconds, whereas in cloud it's minutes, days and week. Whereas data storage period runs in cloud computing consists of months and years. Application, that is M2M, and cloud computing will have data analytic. Location coverage, that is for computing will have local, and cloud computing will be a global, right? So these are the difference between this cloud and fog computing. So here are more differences, that is the requirement of cloud computing and fog edges. Latency time is high, whereas in come to this cloud it will be low. Delay return high, low, right? So these are the points that you need to learn and you need to remember when it's come to the difference between cloud and fog computing. Now this fog versus edge computing, so often they mean the same architecture. Here the main difference is what with exactly where the intelligence and processing are placed into it. Fog computing generally pushes the intelligence down to the local area network level of network architecture, whereas processing data in a fog node or an IoT gateway. Whereas coming to the edge computing, it will place the intelligence and processing and communication capabilities to the edge gateway directly into the smart devices. And that is a single centralized device. Generally, it is responsible for processing data from different endpoint to the network. So this edge architecture or IoT data is collected and handled directly by the connected devices. Now, there are some advantages of fog versus edge computing. So fog will have some advantages like local awareness, low latency, quality as service, but require larger resources, data closer to the user as always, integration of distribution data with cloud services. Right, whereas it comes to the advantages of edge computing, all nodes participate in reduced delay, real-time local analysis would be there, then lower operating cost and network traffic, improved performance, right? So these are the advantages of this fog and edge computing, right? Now coming to the future of scope or future scope of fog computing, so fog as a service, FaaS, that is fog as a service. Now, this FaaS, where a service provider built out an array of fog nodes that across a geographical footprints. So each of these nodes hosts local computation or networking or storage capabilities. It will have these nodes, right? So these nodes can be packaged out for outdoor deployment, right? Street corner cabinets or rooftops. So this fog computing is going to be a key enabler for future IoT services or its infrastructure, and these services will be a key opportunity for service providers, right? So having this world-class fog network directly attached to the traditional mobile networks and open up vast revenue opportunities. This fog network is multi-billion dollar opportunity for network services revenue and network killer, right? So if your fog deployment fall behind the completing network fog capabilities, right? So these are the things that is related ultimately to this fog computing. So yes, here with concluding our session here only. If you have any doubt or query regarding this, just let me know. Thank you so much.